A quadratic function models the projectile's height in meters above the ground in terms of the time in seconds after it was launched. The model estimates that the projectile was launched from an initial height of 7 meters above the ground and reached a maximum height of 51.1 meters above the ground 3 seconds after the launch. How many seconds after the launch does the model estimate the projectile will return to a height of 7 meters? So let's unpack this question. It already tells us this is a quadratic function, so we know the concept behind it. Now we need to model an equation of a quadratic function. Now, anytime you're given the maximum or minimum, that means you know the vertex. And if you know the vertex, the best way to model the quadratic equation is in vertex form, which I'll remind you looks like this. Remember, there are 3 ways to write quadratic functions. My personal favorite, when you know the vertex, it's the vertex form. Why? Because we are told that after 3 seconds, the height was 51.1. So we know the x and y values. Now, if you know this is the vertex, it means we already have the h and the k values. So let's plug those in. So y equals an a value. Remember, you always change the sign of h. Since we have a positive 3, in the parenthesis, it'll be x minus 3 squared. You never change the value of k. If it's positive, keep it positive. If it's negative, keep it negative. And so there we are. Quick reminder, when you write equations in vertex form, you need to have a value for a value for h, and a value for k. Well, we've already found k and h. How in the world are we going to find a to have a complete equation? Enter the other piece of information we were given. We were told that the graph was launched from an initial height of 7 meters above the ground. So that's a point in and of itself. So let me see if I can paint a picture here for you. Here's the x and y plot. We are launching something up in the air, and it's pretty much going to look like that. So if you're launched 7 meters above the ground, that's a point. It's saying the height is 7 when x is 0. At the initial, x is 0. So we have another point given, which is 0, 7, and we can use that to plug into what we have so far to find what the value of a is. So y is 7 equals some a value, x is 0. From this point, it's what I'm doing, minus 3 squared plus 51.1. So quick math, 7 equals 9a plus 51.1. Subtract 51.1 from both sides, and we get negative 44.1 equals 9a. Now we're going to divide both sides by 9, so we have a equals negative 4.9. And so now we have a complete equation. We needed a, we needed h, and we needed k. So let me write the actual equation now. So y equals negative 4.9 quantity x minus 3 squared plus 51.1. Now the question was asking, when you launch this, at what time will we be back at a height of 7? So at what time will we be back on its way down, I guess you see? So it's going up this way, starting at 7, going up. At what time will it get to here, to 7 again? That's where it's 7. So we can do this any number of ways. I think we need to plug this into Desmos to quickly see it. So let's go ahead and do that in Desmos. Okay, I've typed the equation in that we just came up with. Now the question was asking, what is the x value when we are back at 7? And I think the quickest way to do that is literally just type in y equals 7, just have 2 equations and see where they're intersecting. So we can see that the time is 6 seconds that we go back to 7. This is the original one that was given. The launching pad was 0.7. And to get back, it'll be after 6 seconds. And that's the answer to that question. So B. How else could we have done this if you want to stick to the algebraic method? It's basically asking at what time will you be back to 7. So all you do is you plug in a 7 right here and do the math manually if you want to do this in the manual way. But why would you want to do that? The answer would be x equals 6. So use Desmos because it's quicker and it's a time-saving strategy. A machine